Okay, good morning Year 6 and welcome to another maths lesson. Today we're going to start learning about line graphs, and in order to be successful and accurate in today's learning, you're going to need a pencil, some paper, but also a ruler. So if you don't have a ruler, please go and grab a ruler now whilst I share my screen. Okay, as per usual, we're going to start off with our morning arithmetic. Please can you pause the video now and answer these 6 questions. Pause the video and answer these 6 questions on your piece of paper. Okay, we're going to speed up the answer process for these questions, and I'm just going to go through 1 or 2 of the questions, or the harder questions as you would have done them. Your long multiplication, your answer is 20,385, but question 3 is really the main question we'll go through. Remember, first you need to convert it to a top-heavy fraction, then you need to convert the denominators and add them together. 59 over 20 would have been a correct answer, but if you converted it back down to 2 and 19 over 20, that also would be correct. For this question, remember you need to do your bid mass first, so that 1 times 2 is 2, 9 add 2 is 11. Please mark all of those answers for me now, and then we'll go on to our morning reasoning. For your morning reasoning, please let me know if you cannot see the screen. Some children in my class have told me that these questions are quite small for them, so I've done my hardest to make them bigger. But if they're still too small, you need to let us know. We can't see what you can see on your screens. So have a go at these questions. Find the value of the red digit in each number. For example, in the first question, the 3 is in the ones column. Smallest to largest. What have I times or divided these by in terms of our power of 10, and find the missing angle. Pause the video and try those questions now, please. Okay, so again, we're going to whiz through quite a lot of our answers, and I'm just going to focus on this angle question here, which is the harder one. In order to find the missing angles, there's a couple of ways you could have done it. The first way is to remember our fact that in a straight line, the angle is equal to 180 degrees. So I could have seen here, this in total would be 180 degrees. To find angle B, I would do 180 degrees, subtract 104. That would give me a total of 76 degrees. So angle B is 76 degrees. Then the second step I could do there is to see this straight line and this 180 degrees. That tells me that 180 take away 76, well, I already know that's equal to 104 degrees. Now, the other thing that you could have done here, and we haven't actually learnt this yet in year 6, is to know that when 2 straight lines meet, oops, don't know what happened there. When 2 straight lines, and they've got to be straight lines, they can't be bent lines or curved lines, they've got to be 2 straight lines. When 2 straight lines meet, the opposite angles are equal. That means without any calculation, I could find out that what this angle here is 104. I can also see that this is angle B, and this angle here is opposite. So if angle B is 76 degrees, this angle here is also 76 degrees. Now, I'm not saying all opposite angles are equal. I'm saying where 2 straight lines have met, the opposite angles at the intersection will be equal. Okay, moving on to today's learning then. You're going to write the date and the WALT. The date today is the 21st, for those of you who aren't sure. The WALT is we are learning to read and interpret line graphs. Your do now question is 2 questions about pictograms. The first one is to tell me how many satellites were above the Earth in 2016 if one circle is 1,000 satellites. The second one, you're going to have to draw your pictogram in your answer, so drawing circles, maybe half circles, maybe even quarter circles. The question says in 2017 there were 4,500 satellites. Draw that as a pictogram. So please pause the video now to do all of those things. That's the date, the WALT, and 2 do now questions. Off you go. Okay, so by now you should have answered those questions and unpaused the video. Please make sure you're pausing and unpausing the video as per my instructions in order to be as successful as possible with this learning. If you just go straight through the video and you're not pausing and unpausing, you won't have the opportunity to think for yourself, and you're not going to be as successful when it comes to independent work. So my first question, how many satellites above the Earth in 2016? Start by looking at your key. One circle is 1,000, so that's 1,000, 2,000. I can see here this is a quarter of a circle. So to find how much it's worth, I do 1,000 divided by 4. I know that's going to be 250. So in total, the answer to this question would be 2,250. Finally, I need to draw 4,500. I'm going to start with my thousands, 1,000, 2,000, 3,000, 4,000, and I'm now trying to create 500. That's half of 1,000, so I will draw half of a circle. Well done if you got those two answers correct. Remember to mark your answers using a different coloured pen or a highlighter. Now, yesterday we spoke about the difference between continuous and discrete data. We said discrete data was things that you had to count. For example, how many people like the colour blue. We said you couldn't have 2.5 people. It was either 2 people or 3 people. Today's data, we're going to be looking at continuous data. That's data that has to be measured. And in continuous data, you can have any range in between. For example, if the temperature on one day is 6 degrees and on the next day it's 7 degrees, it's had to travel from 6 to 7 and it's gone through every single degrees in between. It's been 6.5, it's been 6.6. You cannot instantly turn from 6 to 7 degrees. So that maybe slow or maybe fast transition has to be accounted for. So continuous data is called continuous because it's continuously changing and we're seeing those values in between. In today's lesson, we're going to be looking at line graphs, and line graphs always represent continuous data. I'm just going to go through what the values are in a line graph and make sure we completely understand exactly what we're looking at. So our x-axis, remembering x is wider and y is longer. On our x-axis, we usually see this represented as time. I'm not saying always, but very often in a line graph, the x-axis represents time. Our y-axis is whatever we're measuring, whether that's the temperature or the height of something, it's whatever we're measuring. And because it's something we're measuring, remember, it's continuously changing. So let's say our y-axis is measuring the temperature in this example, and I'm measuring the temperature on different days. At the time that I measured it on Monday, it was 15 degrees. And at the time that I measured it on Tuesday, it was 30 degrees. But remember, in between 15 degrees on Monday and 15 degrees on Tuesday, let's say I measure at 9 a.m., I've had all of those other times, 10 a.m., 11 a.m., 12:51, and the temperature has been gradually changing. So we first plot on the points that we have measured. At 9 a.m. every day, I've measured the temperature. When you draw the line, what you're actually doing then is making an estimation of the measurements when you didn't measure them. I have not measured the temperature every single second of the day because that would be it would take far too long and it would be far too accurate. It would be hard to represent it on our table, on our graph. So you draw a line between the dots to find your best possible estimate. Now, of course, the temperature on Monday could have gone up and then down again, but roughly it's followed that pattern. So that's basically what you're looking at when you see a line graph. We have our exact measured points, and then we can have an estimation of a value halfway through or a quarter of the way in between them. Right. Remember, I said often our x-axis tells us the time, but it doesn't always. We're going to look at how you could describe the relationship between the cost of a toy and its delivery costs. So without any questions about the specific data, we're just going to look at these two examples. We're going to use these words here. Increase, that means something's going up. Decrease, something's going down. Steadily means it's happening gradually at the same speed. If something isn't steady, that means it's dramatically changing up and down all of the time. I'm going to tell you how I can read this first one, and then you're going to have a go at doing the second one. On the x-axis, I can see the cost of the toy increasing. And as the cost of the toy increases, so too does the cost of delivery. For example, if I've got a low cost of toy, the cost of delivery is also low. But when I go to a high cost of toy, the cost of delivery is also high. So if I was describing this data, I would say, as the cost of the toy increases, so too does the cost of delivery. Both are increasing steadily at the same time. Have a go at writing a sentence to represent what's happening in the first question. Now, this is your first input question for today, so you need to write the subtitle input and underline it with a ruler. Then write question number 1. Next to question number 1, you're going to write a short sentence to describe what's happening in this picture. Pause the video and do that question. Remember, it's important to pause the video and have a go for yourself. Right, you should have already written your sentence. I'm going to now go through the answer. In this one, we can see as the cost of the toy is increasing, for example, here it's 0, here it's 10, here it's 20, the cost of the delivery actually stays the same. It's always £5. So for this question, we would say something like, as the cost of the toy increases, the cost of delivery remains the same. You could say the more the toy costs doesn't impact the cost of delivery. It remains the same. You could say the cost of delivery remains the same despite the fact that the cost of the toy is increasing. But you needed to get the idea that the delivery cost is staying steady, always at £5. Okay, let's look at some specific data then. In this table, you can see the distance that Charlie has travelled throughout the day. On the y-axis, you can see the distance in kilometres, and you can read the scale and see we're going up in 2s. Halfway across then would be 1. On the y-axis, on the x-axis, you can see the time. You can see the time we're measuring every hour, but then there's also 1, 2, 3, 4 increments in between, so each of these represents 15 minutes. Sorry. Okay, so let's look at my question. Whenever you have a line graph, make sure you read all of the information first on the line graph. Make sure you understand what you're looking at. The question I'm going to model 2 of them, and I'm going to go through my steps to success. How far had Charlie travelled at 3 p.m? Okay, step 1, read the question carefully and underline the known value. I need to decide, do I know the time or do I know the distance? How far had Charlie travelled at 3 p.m? At 3 p.m. Here's the value I know, that's the time. Step 2, go to the axis of the known information and find the right value. I know the time, so I need to be looking at the x-axis, which shows time. I need to go to my known value, which is 3 p.m. Okay, now using a ruler, travel in a perpendicular line until you reach the line. Perpendicular means at a right angle, so that basically just means straight up. Oh, you can see that's not quite in the right place. I'm going to travel straight up from 3 p.m. until I reach this line here. That step is done now. Now I'm going to draw at another perpendicular angle, my line going out to the other axis. Because I knew the time, I'm looking for the distance. I can see then that my distance is 6 kilometres. Make sure you include the unit of measure from the question and from the axes. Let's just check I found the right information. How far had he travelled? Is my distance how far? Yes, it is. Okay, so let's look at another question then, using exactly the same steps to success. Read the question carefully and underline the known value. When had Charlie travelled 10 kilometres? In this instance, do I know the time or the distance? I actually know the distance. I'm looking at 10 kilometres. Okay, so now I need to go to the axis to find the right value. I know I'm looking at kilometres. He's travelled 10 kilometres, so I go up to 10 kilometres and I draw my line across at a perpendicular angle. Okay, now draw another line down to the other axis. It's quite difficult to draw these lines perfectly on the computer, but it should be at a perfect right angle. Okay, and now you'll be able to read that information off the second axis. I know this is 4 o'clock, and we've said that each smaller increment is 15 minutes. That tells me the time here is 4:15. Okay, right. On your piece of paper, you're going to have a go at question 2. You obviously can't actually draw on the computer screen, but you can use your ruler to represent where you might have done it. So your question says, at what time had Charlie travelled 12 kilometres? Make sure you know which axis you're starting with and try and find what time Charlie's travelled 12 kilometres. Pause the video now and answer this question. It is essential you're trying to answer these questions during the video so that you can find out what silly mistakes you're making when I go through the answers. So for your one, you knew the 12 kilometres. That means you're starting on your y-axis from 12 to the line. From where you've met the line, you're going to draw your second line down to the x-axis. You can see that's slightly after 5, so that's 5:15 p.m. Remember, each smaller increment is 15 minutes. If you got that answer, well done. If you got a different answer, please go back and re-watch from the beginning of this page as I go through all of the steps showing you what to do. Let's look at the next question then. In this one, I can see that there is a race happening. Okay, and in that race, there are some children who are cycling. You can see here on the y-axis, I've got the number of children cycling. And on the x-axis, sorry, it's cut that off, that's the kilometers they have cycled. So, for example, you can see how many children started the race and how many children finished the race. You can see how far the children got. My first question that I'm going to model to you then is estimate how many children finished the race. The value I know here is finish the race. It was a 20-kilometer cycle, so I know finishing the race is 20 kilometers. From my known value, so I've gone through step one, I've underlined the known value, and now I'm going to the x-axis. Finishing the race is 20 kilometers. Step 3, using a ruler, travel in a perpendicular line. Here I go. Step 4, draw a line to the other axis. Okay, I'm going out straight in a right angle to about here. Now I need to read that scale. For this one, it's asked me to estimate, so that means it's not expecting a completely exact answer. We can't see lots of tiny increments, so it doesn't have to be perfect, but it has to be sensible. That's 100, that's 200, this would be 150. You can sort of imagine where the increments would be. I would say that I would be happy if we had any guess between 175 and 185. For me, I'd probably go with 180 there. Okay, so the next question, sorry, the next two questions, you're going to have a go at completely by yourself. How many children cycled 10 kilometer? Underline your known value, have a go. And then this one's a little bit harder. Complete this statement. Half of the children cycled for at least, Your known value there is half of the children, so you'll have to find half of the children. Please pause the video and have a go at those two questions, remembering it's so important to have a go during the input questions and see which silly mistakes you're making so that I can help you with them. Pause the video and do those two questions. If you have not yet done those two questions, please go and do them now. Okay, oops. How many children cycled 10 kilometers? I underline my known value. Go to the axis of the known information and find the right value. I'm looking for 10 kilometers. I know that my x-axis was the kilometers, so I go to 10 kilometers, which is here. Using a ruler, travel in a perpendicular line until you reach the line of the graph. Okay, mine's a bit wonky at the bottom because it would not let me draw it, but I've gone straight up from there. Now, travel in the other direction to the other axis. Here we go. Again, that's got a tiny bit wonky. Sorry, it's really quite difficult to do this on the computer. There we go. You can see whether or not it's a perpendicular line, so you need to be making sure when you're drawing these that you're trying as hard as possible to create perpendicular lines. Okay, now read the values. So that's 300, that's 350. I'd say you're about halfway between 350 and 400. I would accept anything from 370 to 380 children. Complete this statement. Half of the children travelled for at least kilometres. How many children were there in total? Well, there were 500 children in the race in total. Half of 500 children then, what's half of 500 children? That's going to be 250. So I need to find where 250 is. 200, 250. I go along until I reach the value of the line, and now I'm going down. Remember, you're starting at the value you know and going across to the line. Now I need to read this. This is 10, this is 20, there's 5 jumps in between, 10, 12, 14, 16. At least half of the children travelled for at least 16 kilometres. Again, at this point, if you're struggling with these questions, just go back and rewatch part of the video. Okay, in this line graph, I can see that I'm looking for the temperature. I'm looking for the temperature on Saturday, the 24th of August. You can see that this is the temperature. It's measured in degrees Celsius, and along the x-axis, I have got the time. My question that I'm going to model is, what was the temperature at 12 o'clock? Underline your known value, 12 o'clock, that's time. Go to 12 o'clock and read up. Okay, from 12 o'clock then, I need to find the information on the y-axis. That's the actual temperature. So I go from where my line was out to the temperature. If you can't see the smaller lines in this, you might find it a little bit harder, but there are actually very, very faint increments in between. So that's 20, 21, 22. 22 degrees. Hopefully you can see the very faint increments, but if you can't, you can use estimation, except one up or one down from the answer I'm giving. Okay, Now you need to pause the video and try those questions in green. Remembering it's important for you to have a go at these questions whilst I'm here to help you with them afterwards. If you're not having a go at these questions, you'll find your independent work harder. So do your 2 input questions. Estimate the temperature at 13:15. Think carefully how you'll find 13:15. And then at what 2 times was the temperature exactly 20 degrees? Make sure you're underlining the information you know and going to that axis first. Pause the video now and try those 2 questions. Okay, question 5. I know 13:15. I need to find that on my x-axis. Here's 1:30, here's 2 o'clock. 13:15, I'm looking between 1 and 1:30, it's going to be halfway there. So I found my known value and I found that on the axis. Now I draw my ruler line up to the line and I'm going to draw it now across this way to the y-axis. Okay, so the answer here is 24 degrees, but as I said, I'll accept 1 up or 1 down, so 23 or 25 for those of you who are struggling to read this accurately. Okay, at what 2 times was the temperature exactly 20 degrees? My known value there is 20 degrees, so I go to 20 degrees, but here I'm asked for 2 values, so it's that time there, but also that time there. Can you see how my line goes through 2 different times? So I'll need on my answer sheet this time and this time. If you didn't get those 2 times before, quickly read them now and write them down. First, I'm looking for halfway between 11:30 and 12, that's 11:45. And now the second time in between 12 and 12:30, 2 and 2:30 is 2:15. Those are my 2 times. Well done if you got those questions correct. Okay, this line graph is showing a conversion rate between Jamaican and US dollars. Okay, these are going to be similar questions that you're doing independently with similar graphs. That's why we're going through them together. The first question says, estimate how many Jamaican dollars are in 4 US dollars. So the value I know is 4 US dollars. I need to find US dollars. This is Jamaican, this is US. So I'll go to US dollars and I find where it says 4. I read along and now I'm going to read down. You can see that, you can see where that line is not an accurate measurement. That's why they've said estimate, okay? They're looking for something in the right region. I know that that's 350. If you said 350, it's wrong because it's not actually on 350, it's a little bit after. So for this one, I would imagine 360 is the perfect answer, which means I'll accept anything from 355 to 365, I suppose. So now it's your turn to have a go at a question just like this. This is question 7 of your input. Well done if you've done all of the questions so far. This question says, a coffee from Starbucks in the US costs $4.50. How much does it cost in Jamaican dollars? You'll need to find $4.50 in US dollars and then quickly convert that over into your Jamaican dollars. Pause the video and try that question, please. If you have not yet tried that question, please pause the video and do it now because I'm going to go through my answers. I know $4.50 is US dollars. I go to US dollars. Here's 4, here's 5, 450 is halfway. Mark that one on. Okay, you can see it's a tiny little bit after the line. Now I'm going to go down onto my x-axis then from where that line is. My computer is not doing the right thing, so I'm just going to go down like this. And again, you can see that's not quite in the right place. It needs to be actually a tiny bit to the right of that. I would imagine it's about there. Okay, so again, if you said exactly 400, that's not quite right. It's not exactly 400. I think it's probably around 405, maybe 410. I'll probably accept in between 405 and 415 for this answer. But the key thing is it's not exactly 400, so you can't have written exactly 400. I know my line looks like it, but the computer just was not doing the right thing. You can see, though, here, where we meet is not exactly on the corner, okay? Right, you might also have this kind of line graph where you've got the same axes but different measurements measured in different places. This shows the temperature in different cities in August. When you're doing these questions, you've just got to make sure you're looking at the right coloured line. We can see the cities we're looking at are London, Paris and Madrid. So, in which city did the temperatures steadily increase throughout the month? In which city did the temperatures just go up in a steady line? I can see here I'm going down, up, so it's not Madrid. In what's blue, London, we're going down, then up, then down. So it's not London, whereas in Madrid, you can see it is mostly going up. So the answer for that one is, sorry, in Paris, the answer is Paris. Okay, what was the temperature in Madrid? So find the right colour on the 27th of August, find the right measurement. Then on the 25th of August, how much hotter was it in Madrid than in London? Pause the video and have a go at those two questions. I will be going through the answers afterwards, so don't worry if you find it tricky. That's the whole point of doing these questions now. Okay, what was the temperature in Madrid on the 27th of August? I'm looking for the grey line on the 27th. So I go up to the grey line on the 27th. If you stopped at the orange or the blue line, make sure you're just reading the key. Then once I've found where that is, I'm going to read across, and that tells me 28 degrees. 28 degrees was the temperature on the 27th of August. Now I'm asked on the 25th of August, how much hotter was it in Madrid than in London? That tells me I'm going to have to read two values, Madrid and London on the 25th. So my line needs to go all the way up to Madrid. Okay, oops. All the way up to Madrid, the grey line, and I'm also looking for London, which is the blue line. So I'm looking at both grey and blue. Okay, in Madrid, the temperature was 26 degrees. And in London, my temperature was, the blue line is here, that is 20 degrees. If I'm looking for how much hotter, that's a comparison with hotter, it's subtract 26 take away 20 is equal to 6 degrees. For this one, you've got a bar graph and a line graph together. The line graph's key is on the right-hand side, the temperature, and the bar graph's key is on the left-hand side, the rainfall in millimetres. In which month was there the least rainfall? Rainfall's looking at blue, that's the blue ones, so I need to find the smallest blue line, which is in October. Okay, and I would actually say that's October and December. Have a go at these ones. What was the rainfall in February? Make sure you're looking at rainfall and not temperature. And what was the temperature in December? Make sure you're using the correct axes. Okay, rainfall in February, we're going across to this axis here. Halfway between 10 and 20 is 15. What's my unit of measurement? Millimetres. What was the temperature in December? Temperature is the red line. I'm going to December. The temperature there in between 0 and 5, that's going to be 2.5. My unit of measurement is degrees. We're actually going to skip this question here, and you're going to go straight to your independent work. I've put the steps to success here for those of you who will need to refer to them throughout the lesson. Okay, for these independent questions, you've got 4 different line graphs that I want every single child to answer the questions for. Those of you who are feeling confident, I want you to have a go at this one. And those who are feeling incredibly confident, there's an extension at the end. The extension is open-ended and you're being asked to write your own true or false questions. You could write your own true or false questions for your teacher to have a go at it on Seesaw. So everyone needs to answer the first 4 set of questions, and then those of you who are feeling confident, try the last 2. Pause the video now then to have a go at your independent work. A couple of children have been just waiting for the answers and writing down the answers. It's really obvious to the teachers that's what you're doing because we can see you're copying down mistakes that have been made in the answers. Please make sure you're doing your independent work independently and do not continue watching the video until you are finished. You should no longer be watching this video if you have not yet completed your independent work. Please pause now as I'm about to go through the answers and you have to do this work independently. Okay, I've just popped the answers for the first set of questions up on here and you can mark through them quickly. Okay, the slightly harder ones was the temperature difference because you had to find both temperatures at 10 and 4. At 4 we can see it's halfway between 4 and 6, that's 5, and at 10 you can see it's 8 degrees. So I can see now actually I've made a mistake, I apologise. I didn't read my key carefully enough. Halfway between 4 and 6 is actually 5. 8 degrees take away 5 degrees is equal to 3 degrees. Okay, and then the other harder one, difference between the highest and the lowest. The lowest is 2, the highest is 11. 11 take away 2 is equal to 9. Can't believe I didn't use ruler there, sorry. Right, next group of questions here. Most of them I have popped on the board for you, but we're just going to look at question 11 when you're ready. So quickly mark the first group of questions and then we'll do question 11 together. What's the difference between the hottest and the coldest temperatures on Monday? Monday was the red one. So I'm looking for the coldest temperature on Monday. That's not necessarily the first temperature. Here is the line when it's at its lowest. The coldest temperature is -3 degrees. So that's -3 degrees. The hottest temperature on Monday, remember you're looking at the red line, is all the way at the top of the scale. That's 7 degrees. Okay, so I'm looking for the difference between -3 and 7. -3 is here, 7 is here. To work that out, I'll jump up to 0 by adding 3. And then to get to 7, I add 7. In total, then the difference is 10 degrees. That's our total difference. Make sure all of those are marked before the next group of questions. Okay, question 12 and 13 are on the board. 14 we'll go through now. From when it was planted at the start, how much did Tom's sunflower grow in total? Also, that was meant to say Bilal, sorry. So at the start, how much was Tom's sunflower? At the start, the height of his sunflower was 15 centimetres. What was Tom's flower at the end? 60 centimetres. So to find out how much it grew, I'm looking for the difference there. 60 take away 15 is equal to 45 centimetres. Don't forget your unit of measurement. Okay, question 15 then. It says, which week did Bilal's sunflower have the biggest growth spurt? Explain your answer using data from the graph. In order to answer this question, what I would do is work out how much it grew each week. Okay, so we're looking at Bilal's, that's red, and we're looking at each week. In week 1, it went from 5 to 15, that's 10. In week 2, from 15 to 20, that's 5. This one, it didn't grow at all. Here it's gone from 20 to 35, that's 15. In this one, it's grown 5 centimetres, and here from 40 to 55, it's grown 15. So the answer here is in between week 6 and week 10. In both of those, it grew 15 centimetres. Okay, if you answered that question without using any data, you haven't been careful enough, and in a test, you wouldn't get all of your marks. Okay, in this group of questions then, how much is £400 in euros? We need to go to pounds. £400 is here, reading across to there, and then looking at your euros, that's 550 euros. Unit of measurement is E for euros. Oops. Estimate how many euros there are in £200. £200 is here, and you can see it's not an exact value, which is why it's an estimate. My line's in slightly the wrong place there, but my estimate there would have been 275. Okay, that means as it's an estimate, I'll accept anything. Probably for this one, I would say anything between 260 and 280. Okay, maybe 285 in fact. 260. In fact, I'll be generous. Anything between 260 and 290. Then finally, estimate how many pounds there are in 100 euros. I know euros, I go to 100 euros. Here's my 100 euros. And now I'll go down to my pounds, and that's my estimate. Again, my estimate here, I know my lines aren't quite in the right place, but my estimate would be about 75. So I'll accept anything between 60 and 85 for this one. Okay, this challenge was a question. So if you've marked all of the questions, sorry, this question was a challenge. So if you finished doing all of the questions that you actually did, please just watch these ones so that you know how you could have done them next time. In the daytime, how much would it cost to make a 4-minute phone call? I'm looking for daytime and I'm looking for a 4-minute phone call. I can see that's 20p. Steve makes a 10-minute phone call. It costs 17p. Did he call in the daytime or the evening? I know 10 minutes and I'm going to go across to 10 minutes. Is 17p in the evening or the daytime? I can see daytime is 50p, so this one is an evening. How much does it cost to make a 6-minute phone call in the evening? So I know my time is 6 minutes and I'm looking at the evening one. I'll go up to 6 minutes and then across, that's 10p. These ones weren't necessarily harder. I just thought some of you might not want to do quite so many questions. This one, oh, I don't have my reasoning question. Oh yeah, I haven't got my reasoning question on because it's up to you what you've said your questions are. So please don't forget to upload all of your work with all of the answers, and I'm looking forward to seeing everyone's fantastic work on Seesaw. I will see you all tomorrow for another maths lesson, and well done for all of the hard work you've been doing over the past couple of days.